Hi everyone, we're twin3. I'm Leon. Today, we're excited to introduce our project Twin Matrix, Injecting Human Soul into AI Agents. On most platforms today, identity is silently collected, inferred, and used, often without users fully understanding how. Twin Matrix takes a different direction. Our project centers on giving users control over their identity and preferences. By defining their own matrix, covering aspects like digital, social, or physical, they empower an agent to act on their behalf. The agent uses these preferences to match tasks, like a mission offered by a brand, and completes it to earn rewards. Here on the homepage, we can see our main concept: bring your 256D self to life. The 256D represents the structured identity vector that defines you, not as data collected by platforms, but as something you actively construct. Now we click Start. On this page, we can see the core identity layer. For example, we can select age, gender, education, income, work status. These are not mandatory disclosures. They are optional identity signals chosen by the user. We intentionally design this flow to feel like self-expression, not interrogation. Next, we move to the Signal Layers page. Here we can see different identity aspects that shape your state: music, art, reading, food, travel, finance, gaming. For this hackathon, we'll only enable sports preference. We'll scale across more dimensions in the future. Now we enter the Baseline page. On this screen, we can see exercise frequency, session duration, and average daily steps. For example, exercise frequency 1 to 2 times per week, session duration under 30 minutes, daily steps under 3,000 steps. Now we move to the Activity Preference layer. Here you can see most frequent activities, outfit style, and brand preferences. For example, we select running and cycling as top activities. For outfit, we select casual comfort. On the right side, we select Nike and Lululemon as a preferred brand. Now we reach the Soul layer. This layer captures intention and instinct. For example, do you train for performance or experience? Do you train alone or with others? Here we adjust the sliders. These sliders help shape deeper personality vectors behind the physical signals. At this point, the identity construction is complete. These data are not stored as plain text answers. Each selection contributes to the archetype distribution. Those archetypes are combined into a 256-dimensional twin matrix vector. This vector represents your structured preference architecture. After the calculation, we are brought to the Identity Preview page. Here we can see a projection of the twin matrix in 256 dimensions. At this stage, the identity is not yet sealed. The system allows the user to review everything before recording it on chain. On the right side, we can see several indicators: quadrant position, identity density, and the layer mix distribution. Here we can clearly see that physical accounts for 52%, digital 14%, social 21%, and spiritual 14%. This gives a structural overview of how the identity is distributed across layers. Once Mint SBT is clicked, the transaction is submitted to the blockchain. Here we can confirm that the SBT has been minted successfully. We can also open our wallet to check the SBT. Minting the SBT does not yet finalize the matrix data. The user needs to submit another transaction to update the matrix projection on-chain. After minting and updating the matrix, we arrive at the Identity State page. Here we can see the token ID, latest version, the connected wallet address, and we can also see the state insight. If we scroll down to version history, we can clearly see both V1 and V2 recorded separately, each with its own digest and block number. What's important here is how versioning works. When we mint the SBT, that initial recording becomes version 1. Then when we perform the first on-chain matrix update, that creates version 2. So versioning begins the moment identity is sealed. Minting defines the container. Updating defines the structured identity state. Now let's demonstrate identity evolution. If the user clicks Reconfigure Preferences, we are brought back to the Signal Layers page. Here we can redefine the identity signals from scratch. For example, we can adjust preferences and walk through the process step by step. Once we proceed, the system recalculates the archetype distribution and generates a new 256-dimensional matrix. After the recalculation, we are taken back to the identity preview page. Here we can review the updated projection before committing it on-chain. Once we click Update Matrix, a new transaction is submitted. We can confirm that the transaction is successful. After confirmation, we return to the Identity State page. Now, if we scroll down to Version History, we can see a new version 3 here. This demonstrates that identity in Twin Matrix is not a fixed profile. It is a versioned, traceable structure. Each update becomes part of the identity timeline. At the bottom, we can see a section called Bound Agents. Right now, it says no bound agents yet because we haven't created any agents yet. And this is what we are going to do next. Now let's create a new agent. Here we create a new agent. First, we give it a name, Fitness Testing Agent. Twin Matrix divides identity into 4 quadrants: physical, digital, social, and spiritual. Users can choose which scope the agent is authorized to use and for how long. This permission is critical. Technically speaking, all on-chain data is public, so it's not about whether the agent can see the data, it's about whether the agent is formally authorized to use specific identity signals as the basis for matching tasks and execution. For example, if we grant the physical scope, the agent is now bound to use the physical layer signals, such as sports preferences, as its authorized matching criteria. Later, when a merchant agent assigns a task, it can verify on-chain whether this agent was properly authorized to use those signals. If the agent matched a task without proper authorization, the merchant can simply reject it. So permission here is not about hiding data, it's about establishing verifiable legitimacy. Now let's actually create the agent. To make this transparent, I'll open the browser inspector. When we click Create Agent, we can see an API request being sent to the backend. This request registers a new agent instance. The backend then responds with a Telegram bot link. We click the Connect button, switch to Telegram, and we click Start. At this moment, the agent activation process begins. The backend uses the official BNB Agent SDK to generate a new agent wallet. This wallet is fully independent from the user's wallet. Meanwhile, on the front end, we are continuously polling the backend to check whether the agent address has been generated. Once generated, the agent executes an ERC 8004 on-chain registration. This establishes the agent as a valid on-chain identity delegate. Here we can see that the tax has been confirmed. Once the backend finishes wallet generation and completes the 8004 registration, it returns the agent address to the front end. Now the system asks the user to bind this agent to their SPT. This step records 3 things on-chain: the agent address, the authorized identity scope, and the authorization duration. This is the critical trust binding step. We click the button, submit the transaction, and once confirmed, the agent is officially authorized under this identity. After completion, we click Return to Dashboard. Now in the Agent Studio, we can see the agent we just created. It shows agent wallet address, authorization scope, and expiry. This confirms that the agent is registered on-chain, bound to the SBT, and operating under the committed identity. Now we switch to Telegram. When the user types Get Permission, the agent reads the authorized scope from the SBT contract. These permissions are written into the agent metadata. This becomes the agent's sole configuration. Before I continue, there is one thing I want to clarify. In this demo version, the mission flow is mocked. There is currently no real brand agent giving tasks to our agent. Instead, after permission retrieval, our backend will generate a simulated mission to demonstrate how the interaction would work in production. After permissions are loaded, we can see the scope and expiry granted to this agent, and then backend pushes a simulated task to Telegram. Here we can see a matched mission. In this scenario, a performance footwear brand analyzes trail cushioning response through anonymized endurance and impact signals with a reward of 0.9 USDT. Oh, that's because each task expires after 30 seconds. I set this rule purely for demo purposes. Let's try again. And we got a new mission show up here. After accepting the task, the agent begins working on the mission, and after a few seconds, it reports that the mission has been completed. We can see the ongoing task in the dashboard. When the user clicks Submit, USDT is transferred to the agent wallet. In this demo, the twin3 backend directly sends USDT from a system wallet since there is no real brand agent client yet. Here we can confirm the transaction on-chain. 0.8 USDT has been successfully transferred. We return to the Agent Studio page where we can see the USDT balance has been updated. The agent's wallet now shows 0.8 USDT. Then we switch to the Task Records page where we can see the mission status has changed to completed and an expired mission is also listed. Now let's demonstrate another important capability. A single SBT owner can create multiple agents for different purposes and interaction strategies. This allows users to separate how their identity is expressed across different contexts. For example, one agent might be authorized only for physical signals to match sports-related tasks, while another agent could be granted digital or social signals for completely different use cases. In other words, identity remains unified under the SBT, but execution strategies can be modular across agents. We name it Daily Activity Agent. During creation, we can assign a different authorization scope and define a separate duration. This new agent will have its own wallet, its own authorization scope, its own task history, and its own matching behavior. Here we can see that the backend has successfully created another agent. We then check BSC scan to confirm that the ERC 8004 registration was also successful, giving this agent its own on-chain identity. Next, we return to the website and bind the agent to my SBT. Once the transaction is confirmed, we go back to the Agent Studio page where we can see the second agent we just created. Since we now have two agents, we can switch between them in Telegram using a command. Here we can see that each agent has a different authorized scope loaded. Finally, I want to briefly talk about the future. We plan to integrate X.402 protocol. X.402 enables pay-per-use on-chain payments without third-party platforms like PayPal. In the full vision, the brand agent acts as the client. The human agent acts as the service provider. The brand agent requests payment requirements, signs the transaction, and automatically settles rewards on-chain. This makes fully autonomous agent-to-agent commerce possible. In this demo, since there is no real client agent, we use a simplified back-end transfer, but X402 is our next step infrastructure for automated settlement. This is the complete twin matrix demo, from identity definition to agent authorization to automated task execution and reward settlement. Twin Matrix creates a system where identity is user-defined, agents act on your behalf, and everything is verifiable on-chain. Thank you.